Question number 7 is a vectors question. So we have a parallelogram here. So what we know about a parallelogram is that the opposite sides are parallel and the opposite sides are also equal. So this side and this side is equal, this side and this side is equal, but at the same time this is parallel to this and this is parallel to this. So what we know about vectors is that if we have vectors, parallel vectors, they have the same direction but they're proportional. So if this vector is a, this would be some number into a. So parallel vectors are not exactly equal but they're proportional. But if it is mentioned that it's a parallelogram, that means the vectors are both parallel and they're equal. That means the value of k is 1. So if OA is 4a here, then this BC, this would also be 4a. And similarly, if OB is 6B here, then this AC, the printing is not, this AC, this portion would also be 6B, because in a parallelogram, the opposite vectors are not only parallel, they're also equal. Okay, that information is done. The next, they have given a ratio. BQ is to 3QC. That means if this is BQ, if this is 3, this is 1. So BQ divided by QC is 3 divided by 1, or 3 is to 1. So the ratio is this. They have also given us the ratio. So let's start the question. Question number A. Question number A says write down QC. We don't have to show anything, just write down. So QC, we can use the ratio. So we know this BC and this OA, they have the same vectors, 4A. So we can write QC equals to 1 of 4, 1/4 of the entire vector, which is BC. So which is BC. So this would be 1/4 of 4A, and the 4 and 4 would cancel and A would be the vector. So this is question number A. Question number B, we have to talk about that this triangle is similar to this triangle. For this, the rule of similarity must be clear. So if you have two triangles and the bases are parallel, like this one, OA and QC, then since it's a parallelogram, the bases are parallel. When this happens, they have to be similar triangles, because similar triangles means each of the angles are equal to each other. So this angle equal to this angle, because there's corresponding angles. Similarly, this angle equal to this angle, this is also corresponding angles, and this angle over here, it's the common angle. So in order to show that the two triangles are similar, what we can do is we can write in triangle CPQ and triangle APO. So we are talking about CPQ. The smaller triangle is coming first and this larger triangle is coming later on. We can say that angle, this angle CQP, angle CQP equals to angle AOP. AOP. They are corresponding angles. So you can write OA is parallel to QC. So corresponding angles. Corresponding angles. So that's the first rule. The next one is this angle equal to this angle. So we can write angle PCQ equals to angle PAO. They have the same reason as before. OA is parallel to QC, so corresponding angles. Corresponding angles. And the final angle has to be equal to each other. So the final angle has to be for this triangle. Remember, since we are mentioning this triangle first, we always mention the angles of this triangle first. So CPQ, angle CPQ must be equal to the angle APO. So angle APO. We don't have to give any reason. We can just write it's the third angle or the common angle. So they are third angles. If two of the angles are equal, since the sum of all the angles is 180 degree, the other angle has to be equal, because if you subtract the two equal angles from 180 degree, the leftover is equal. So therefore triangles are similar. So this question is not just vector, this is really similarity of geometry. So once you know that two triangles are similar, then it means that this side this side of the first triangle, let me name it O, A, C, P, and this is Q. So since two triangles are similar, that means the angle this opposite this side we have CP. So this CP divided by, for this entire larger triangle, angle of the same angle, this angle and this angle is equal, opposite side is AP. So AP equals to, then if we take this angle, this would be QP divided by, if you take this angle for the larger triangle, it would be OP. They should all be equal. So that's the ratio. And not only that, we have another one, which is this common angle or third angle. Opposite this is CQ, and opposite this bigger triangle is OA. So all these three ratios are equal. So for that, we can find the value of CP using the similarity rule. So for finding CP, this is CP, this particular angle is CP, so we can use similarity. So let's use similarity. So CP vector, this is the angle, so opposite this is the other one, AP vector. So CP divided by AP equals to, we can write CQ or QC, which we found in the previous sum, QC divided by OA. So that is the ratio of similarity. So using that similarity, we can write that CP equals to QC. QC is A, OA is 4A, and if we multiply it with AP, AP is going to be 6B plus CP. So we can write 6B plus CP like that. It's like algebra. So we can cancel this off. This is 1 and this is 1 by 4. So if we cross multiply, this is what we get. We get 4CP equal to 6B plus CP. Therefore, if we just change the side, we write 3CP equals to 6B. Therefore, CP equals to 2B. So we find that CP is 2B. So this was question number 1. Now we can write number 2 of AP. So we wrote AP as, so this is going to be AP equals to 6B plus 2B. That should be 8B. Remember, so this AP is made up of this 6B and this CP. So CP is 2B. So together it becomes 8B. So this is not more of a vector sum. It's more a geometry similarity sum. It falls in the topic of similarity. Now we have another question of similarity, is similar areas. So question number D is about similar areas. So we have triangle CPQ. So if you take a look here, so we have triangle CPQ, this triangle. Let me call this triangle A. So this triangle is triangle A, A1. And this entire triangle is triangle A2. So we can write triangle A1 divided by triangle A2 is side 1 by side 2 whole squared. It would be convenient to draw the triangle again. So this is the triangle. So this is A, this is O, this is C, this is Q, and this is P. So we have these two triangles. So we have ACP, OQP, ACP, OQP. So we have this. So we know this is 4 and we know this is 1. So we know this is 6 and we know this is 2. So these are the ratios that we know. When we find the areas, we can write area 1, triangle CPQ divided by triangle, the larger triangle OAP, that is going to be side 1. The side 1 of this is 1 divided by side 1 of this is 4 whole squared. So that makes it 1 by 16. And we know that this triangle CPQ is 4 centimeters squared. So 4 centimeters squared. So this triangle OAP, the larger triangle OAP, so that is going to be triangle OAP equals to 4 into 16 centimeters squared. and that is going to be 64 centimeters squared. So if the larger triangle is 64 centimeters squared, if the smaller triangle is 4 centimeters squared, so the leftover quadrilateral, so we can write, so area of ACQO quadrilateral is going to be 64 minus 4 equals to 60 centimeters squared by geometry. The coordinates of the vertices of triangle ABC are ABC. Okay, this is a matrix transformation sum. So nowadays, most of the graph would be printed, the axis would be printed, but previously we have to put the axis ourselves. So this is what we have to do. So x has to be 0 to 7, and each would be 2 squares. So 2 centimeter means 2 squares. So 0 to 7. So let's take this. So this is x. So we need 2. So if we start from here, so this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So y has to be from -2 to 3. So that means if we draw it here, so this is the y-axis. So -2, if this is 0, so this is -1, and this is -2. This is 1, this is 2, and this is 3. So this is 1, 2, 3, 4, 5, 6, 7. So that's the graph. So the first thing that we have to do, we have to put this on the graph paper. So A is 1, 1, B is 2, 0, C is 2, 2. So 1, 1 is starting from the origin. So 1, 1. So this is A. 2, 0. So this is B. 2, 2. So 2, 2. That is C. So we have to draw this triangle. So A, B, C. So that is the first thing. The next thing that we have to do is we have to calculate a matrix. This 3 points has been rewritten as a matrix. So 1, 1 is 1, 1, 2, 0 is 2, 0, 3, 3 is this. This is A, this is B, and this is C. So what we have to do is multiply the matrix of the object with the transformation matrix, and we have to write down the answer. So let's do this here. So question number B is, P is 2, 1, 0, 1, and the matrix that we have to multiply this with is 1, 2, 2, 1, 0, 2. So the answer would be, let me do this very quickly. So the row here would be the column here. So 2 ones are 2 plus 1 ones are 1. Then this row would be multiplied with this column. 2 twos are 4 plus 1 into 0 is 0. Similarly, this would be 2 twos are 4 plus 1 twos are 2. Then the next row is going to be 0 into 1 is 0 plus 1 ones are 1. So this would be 0 plus 1. This would be 0 plus 0 because 0 into 2 is 0. 1 into 0 is 0. Then 0 into 2 is 0. 1 into 2 is 2. And what we would be having is 3, 1, 4, 0, 6, 2. So that would be the product of the matrix. Now what we have to do is we have to put this into the graph paper, and we have to name it A prime, B prime, C prime. That's question number C. So we have to write this. Question number N, done in graph. Question number C, done in graph. So A prime is going to be 3, 1. B prime is going to be 4, 0. C prime is going to be 6, 2. So 3, 1 is this, A prime. 4, 0 is this, B prime. And 6, 2 is this, C prime. Let me check again. 3, 1, 4, 0, 6, 2. 314062. So it's correct. Let me draw the triangle. This is this. This is not a straight line, but you have to use a scale. So this is the image. Now the next thing that we have to do, we have another matrix Q. So 0, half, minus 1 by 4, 1 by 4. So we have to multiply this and we have to find another triangle. So let's do question number D. So we have to multiply 0, half, minus 1 by 4, 1 by 4 with the previous image that we just found. That would be A prime, B prime, C prime. So that would be 314062. So let me do this very quickly. So when we multiply this, 0 into 3 is 0, plus half into 1 is half. So this would be 0 plus half. Then this row with this, 0 into 0 is 0, 0 into 4 is 0, half into 0 is 0. So this is 0. 0 into 6 is 0, plus half into 2 is 1. Then the next row, minus 1 by 4 into 3 is minus 3 by 4, plus 1 by 4 into 1 is 1 by 4. Then minus 1 by 4 into 4 is minus 1, plus 1 by 4 into 0 is 0. Minus 1 by 4 into 6 is minus 6 by 4, plus 1 by 4 into 2 is 2 by 4. So the calculation is going to be 0 plus half is half, 0, 1. 1 by 4 minus 3 by 4 is going to be minus half. Minus 1 plus 0 is minus 1. And this is going to be 2 minus 6 is minus 4 divided by 4 is minus 1. So now we have to put this in question number D. We have to draw and label triangle A double prime, B double prime, C double prime. So let's do that. So what we have to do here is minus half, half minus half. So if this is half, then minus half is going to be here. So this is A double prime. The next one is 0 minus 1. So if this is 0, minus 1 is this. 0 minus 1 is B double prime. Then C is 1 minus 1. So if this is 1, this is minus 1, this is C double prime. So this is the triangle. So we then write done in graph. Done in graph. Okay. So the next question is triangle ABC can be mapped. Triangle ABC is this first triangle, can be mapped into triangle A double prime, B double prime, C double prime by rotation followed by an enlargement. So what they're saying is that from this triangle you can directly get to this triangle, from this to this, by doing two transformations. They're saying first you have to do a rotation and then you have to do an enlargement. Describe fully the rotation and the enlargement. That's the question. So let's take a look at our options. So this is what we have. If this is the original object, there can be two rotation. It can either go 90-degree anti-clockwise or it can go 90-degree clockwise direction. So there are two options for rotation. So if we start from triangle ABC, so if rotation is going on, so it has to be a 90-degree clockwise rotation. So the first option would be 90-degree clockwise rotation. The next option that we have is enlargement. Now if you take a look at this triangle and the original triangle, you will see that this triangle is larger than the image. That means the image has a scale factor smaller than the original. If the scale factor was 2, it means the image would be double the size. But in this case, let's see what is the size of the image. Here AC, or if we take a look at BC, it is 1, 2, 3, 4. So 4 boxes. If we take here B prime, C prime, it is 2 boxes. So previously it was 4. Now the image is 2. So from 4 to 2, that means it has halved. So the enlargement has a scale factor of half. So that is the enlargement. So when we have to mention the rotation followed by enlargement, the rotation would be 90-degree clockwise degree rotation and the enlargement would have a scale factor of half. So let's write this down. So question number C, triangle ABC is rotated by 90-degree clockwise, and then there is an enlargement of scale factor half. Now, it's a good idea to mention the center of enlargement if you're able to do that, but if you're unable to do that, then it's a good idea to mention the origin as the center, because that's the standard. So you can write with center 0 0 to give the image triangle A double prime B double prime C double prime. This is a probability game sum. That means they're going to tell you how the sum has to be played. So there are two spinners. The first one has 1, 2, 3, 4. So you spin this needle and you get a score. Then you move on to the second spinner and it has 1, 2, 3, 4, 5 numbers. You spin it and you get a second score. Your total score is the total. For example, this one has 2 and the second spinner points at 1. So 2 plus 1, it's 3. So that's the game. So let's start. So the first table is relatively easy. So this is the first spinner and this is the second one. All you have to do is write down the total. It might appear to be different, but it is actually straightforward sum. So 1 plus 2 is 3. This is 4 and this is 6. So 2 plus 1 is 3. So this is 4. Then 2 plus 4 is 6. Then 3 plus 3 is 6. 3 plus 4 is 7. 3 plus 5 is 8. Then 4 plus 1 is 5. This is 6. This is 7. This is 8. So this is it. This is pretty straightforward. You add up the two scores. Now what we have to do, the probabilities of getting a total of 1 or 2 or 3 or 4. For spinner 2, the probability that the pointers stop in the probability is given here. So now this is pretty straightforward because you know that the total probability is 1. So if you want to find the value of x, you can write 3x plus x plus 4x plus 5x plus 2x equals to 1. Let me repeat. They're saying for spinner 2, the probability of getting a 1 is thrice x, the probability of getting a 2 is x, the probability of getting a 3 is 4x, probability of getting a 4 is 5x, and they're giving the probability. Then you have to find x. It's easy. You have to remember total probability is always 1. Okay, so you can add it up. So the total is 3x plus x is 4x, 4x plus 4x is 8x, 8x plus 5x is 13x, 13x plus 2x is 15x. So we can write 15x equals to 1. Therefore, x equals to 1 by 15. That makes it, this is going to be 3 into 1 by 15. So this is going to be 3 by 15. So this would be 3 by 15. So this is 1 by 15. I'm putting the values of x. This would be 4 by 15. This would be 5 by 15. Of course, it can be simplified to 1 by 3. And this would be 2 by 15. So that's the probability. So the next question, we are going to take the probabilities of spinner 1. The probability that the pointer stops in any one of the section numbered is 1 by 4. So what they're saying, if you want to find the probability for spinner 1, and if you make a table just like this, let me make a table like that. If you make, this is for spinner 2. This is for spinner 2. If you make a table for spinner 1, just like that, it is going to be, so that would be like this. So we have 1, 2, 3, 4. So this is the sectors and this is the probability. So each of the probability would be 1 by 4, 1 by 4, 1 by 4. That's what he's saying. So each of the probability for spinner 1 would be 1 by 4. That's what it says. So let's start. So question number C, number 1. So what would be the probability of getting a score of 1? So let's look at this total table. So there is no chance of getting a score 1 because in this table, these are the totals. There is no total that we get 1. So the probability of getting a total of 1 is 0. Question number 2. So question number 2 says, a total of 3. So let's see, we have this one, we have this one. So there are two ways of getting a 3. So we can get a 3 by 1 and 2. So 1, 2, or we can get a total of 3 by 2, 1. So that would mean 2, 1. Remember, 1, 2 means 1 in the first spinner, the probability is 1 by 4, and 2 in the second spinner, the probability of getting a 2 is 1 by 15, or 2 in the first spinner, which is 1 by 4 for the first spinner, and 1 in the second spinner. Probability of getting a 1 is 3 by 15. 3 by 15 means 1 by 5. So if we calculate this, it turns out to be, so 1 by 4 multiplied by 1 by 15 plus 1 by 4 multiplied by 3 by 15, and the probability turns out to be 1 by 15. So that's it, that's the probability, 1 by 15. Number 3, so we want a score of 6. So let's check the total. We have 1, 2, 3, 4 situations where we have a total of 6. So how many ways can we get a 6? So the first one is 1, 5, and then we have 2, 4. So let me write this down. Getting a 6 is 1, 5. There is no option of 5, 1 because the first spinner does not have the number 5. So another option is 2, 4, and it can be 4, 2. Another option is 3, 3, and that's it. There are 4 ways of getting a 6. So let me see this again. We have 2, 4, we have 4, 2. So 2, 4, 4, 2. So that is one option. So 2, 4, 4, 2. Then we have 1, 5, but there is no 5, 1 because spinner 1 does not have the number 5 here. So that is one option. So 1, 5 is another option, and the final option is 3, 3. So these are the 4 ways of getting a 6. So let's do the calculation now. So the calculation would be 1, the first spinner, that is 1 by 4 because the probability of every number in spinner 1 is 1 by 4. The second one is 5. 5 means 2 by 15. So this would be 2 by 15, or 2, 4. So 2 again is 1 by 4, and 4 is 5 by 15. So this would be 5 by 15. Then we have to take the other option, 4, 2. Usually what we do is we just multiply when we have the same thing, different orders of the same thing, we just multiply, take one probability, multiply by 2. But this, since this is a game sum and they're making the rules themselves, we cannot be sure about that. So 4, the first spinner has every probability 1 by 4, and getting a 2 here is 1 by 15. So this would be 1 by 15 plus 3, 3. So the first one getting a 3 is 1 by 4, and the second one getting a 3 is 4 by 15. So 4 by 15. So let's do the calculation here. So the calculation turns out to be, let me do this quickly, 1 by 4. So this 2 to the 4, so 1 by 30. So this would be 1 by 30 plus, so this would be 5 3s are 15. So 3 4s are 12. So 1 by 12. So 1 by 12 plus, this one is 1 by 4 into 15 is 60. So this would be 1 by 60. So 1 by 60 plus, this one 4 and 4 cancels, it would be 1 by 15. So it would be 1 by 15, and the probability is 1 by 5. So that is the probability 1 by 5. So I would like to mention one thing. The probability story sum, it doesn't matter what the story is. It would be it could be some sort of a game that would be explained in the question. It is straightforward question, but it might not appear to be so. So all you have to remember the basic rules of probability.